Hey everybody, this is Mr. McKee again with Net 125. Today I'm going to be going over Packet Tracer 11.9.3, which is VLSM, Design and Implementation Practice. And remember, VLSM is Variable Length Subnet Mask, or masking, all right? And that's basically you're giving a block of IP addresses, and you don't want to waste your IP addresses, so you're going to try to make all your subnets as small as possible while meeting the requirements. All right. The big thing is meeting the requirements. All right. You have a little room for expansion, but basically meeting the requirements. All right. Also, this. Let's see. If you're in my course, your Word document is not going to have any of this addressing table information because this is going to be specific to the version. Notice there's three possible topologies, so three possible versions of this packet tracer. So if you hit reset activity, you're probably going to get a different version of the packet tracer. So try not to do that unless you're completely, lost and you want to restart. All right, so if you're in my class right here, this is the Word document. All right, just like I said before, you will receive one of the three possible topologies. You're going to go in here, and I know you have to reformat it because I don't change the formatting like I should. But if you give it, actually, if you format painter this cell right there, click there, click here. Whoops, let's format painter this. Alright, come on, format painter. Alright, format painter that. Alright, that gives you all your blanks and everything. Do like this, and edit undo because I'm going crazy. Alright. That's right there. Alright, so you got your interfaces, you're going to put in the device. Alright. Obviously the VLAN one, that'll be switches, NICs, or PCs, and each of these are going to be a router. All right, 2 gigabit interfaces and 1 serial interface. All right, also you're going to fill in down here your variable length subnet masks. All right, so probably you want to go up here and format painter this. And that'll show all blanks, and then just go through here and delete those. All right, make sure those are done in red, please, so I can easily grade them. All right, and then there are some questions, but the big thing I'm worried about is you filling in all of this correctly and filling in the your subnets. All right, so I'm just going to move this off the screen. I'm going to do some of this stuff off the screen, but then I'm going to show you guys what I'm looking at. All right, because based on the version that you have, the naming convention will be different, and the interfaces interfaces probably won't be different. Switch names, router names, things like that will be different. Obviously, the subnet that you're given, that's going to be different. All right. So let's see. In this activity, you're given a \24 address to use to design a VLSM addressing scheme. Based on a set of requirements, you will assign subnets and addressing, configure devices, and verify connectivity. All right, cool. Not too bad. Short lab, but don't be fooled that it's super easy. All right, VLSM is just one of those things that it takes a while to get. Don't think you're the only one if it takes you a little bit. Everybody has that issue, I think. All right, but determine the number of subnets needed. You will subnet the network address, this right here, \24. So right there, I know that, okay, 24 bits are my host address. So I have 8 bits to assign host addresses to. All right, so with 8 bits, I have a possibility of 256 unique addresses. All right, minus the network address and minus the broadcast address. That's 254, but then when I start chopping them up in different subnets, I'm going to have even less because each each subnet's going to have its own address, own network address, and own broadcast address. All right. So right here, here's a question: how many subnets are needed in the network topology? Now, maybe a little misleading. All right. Notice it's saying switch 1, and they're naming the each LAN by the switch it's connected to. All right. So there's 4 there. How many subnets are needed in the network topology? Well, one thing you need to figure out, and I'm probably about to sneeze. Sorry. All right. You need to figure out, okay, definitely the LANs are going to be part of the network, but is this WAN connection, the red Z, is that those 2 serial connections, is that going to be a network within my network, or is that going to be like a network, internet connection where I don't own that? I can't assign addresses to that. But if you skip down to step 2 under part 1, which subnet mask will accommodate the number of IP addresses required for the connection between remote site 1 and 2? So when it says that, I'm just assuming that we're going to have to use some of our addresses for that remote network also. All right. And I don't know if I mentioned it now, but make sure if you guys hit reset activity, if you get lost and need to fix something and you want to start from scratch, you're probably going to get a different version of the packet tracer. All right. So with this noted, I'm just going to assume that that's going to be part of my VLSM. All right, but let's answer these questions first, starting with step 2A. Now I'm using my no calculation subnet IP version 4 subnetting calculator. All right, and remember I say don't use an actual calculator because it's just gonna make it tougher to understand this for the certification exam. All right, but looking at this though, we're working with a \24. So \24, without breaking up these in different subnets, we got 256 possible addresses. Notice 255, 0 is our first address, so that 256 total. All right, if I start chopping up the subnets, all right, and borrowing bits starting from the left to the right, if I borrow 1 bit, I'd have 2 possible subnets, 4, 8, 16, 32, 64. And remember they end right here because if you have a \31 or 32, that's not a valid subnet mask, right? You will see, like we saw in the last lab, if you look at a router configuration for routing, the IP routing, you'll have a \32 that corresponds to the actual interface, all right? So if you see it 255.255.255.255, that's referring to just that specific interface IP address. All right, and 31, you just really can't use that for much of anything that I've seen. All right, and if you start, we're not going to have to worry about this, but if you start borrowing bits, that's what your 4th octet's subnet mask address will be. All right. So I try to make this very information-rich spreadsheet, but at the same time, the calculators are really awesome. They tell you, they help you out, but they're not going to help you out when you take an exam because it's not going to let you use a calculator. All right, you need to understand how this works, anyways. All right, so let's see. Which subnet mask will accommodate the number of IP addresses required for switch 1? So switch 1's 7 hosts. All right, so if I come over here, all right, 7 hosts would actually be, the smallest subnet would be a \28. All right, it can't be a 29, even though it has 8 bits. All right, because one network and one broadcast bit, or one network and one broadcast address, so you only have 6 usable host addresses. All right, 15, same thing. All right, you have to do a \27 for that. Yeah, \27 for that, \27 for both of those, it looks like. A 58, you can use a \26. All right, And for some reason, it really didn't mention that yet. You know, it didn't list it here, but which subnet mask will accommodate the number of IP addresses required for a connection between remote site 1 and 2. Well, that's going to be \30. That's really, really common. Router-to-router connection, \30. Same thing as that .252 for your fourth octet in your subnet mask. Get used to seeing that a whole bunch, especially working with routers. All right. So we did which subnet mask will accommodate it, and then how many usable host addresses. All right, so switch 1 had 7, so we have to do a \28 for that. How many usable addresses? 14. I'm going over this again just so you guys can see it. All right, 15 hosts for switch 2. All right, you need at least a \27. That'll support 30 hosts. All right, a switch 3, same thing. Switch 4, give you 64 hosts. Or I'm sorry, 62 hosts. All right, and then this one right here, jump down to E, which subnet mask will accommodate the number of IP addresses required for remote site 1 and 2. So that would be a \30. So notice number of addresses is 4, but usable host addresses are 2. So router to router is all you got. All right, so let's move up to this. Design the VLSM addressing scheme. Divide 192.168.72.0 \24 network based on the number of hosts per subnet. Use the first subnet to accommodate the largest LAN. Use the first subnet to accommodate the largest LAN. All right. So what they're doing, they're making this kind of like, they're not just giving it to you, but what you want to do is look at your topology, all right? And it doesn't matter if you have, 100 or you have 1,000 or 10,000. You look at all your hosts, all right? Your largest subnet's going to go first, all right? So what I can do, use the first subnet to accommodate the largest, use the second subnet to accommodate the second largest. All right, so I'm going to do these one by one, and my email keeps beeping, but anyways. All right, so let's see. So my first network is going to be the largest. All right, and I'm just going to make it, don't worry about this IP address, I'm going to make it up, but 192.168.72.1. All right, that's just a IP address that's going to be my first network. All right, subnet mask, we're going to have 58 hosts. So how many, which site are we going to use for 58? It has to be the one that's just larger than that. So it's going to be this one that has 62 hosts possible. So it's going to be a \26. And if I look down here, that's a .192. So 255.255.255. Notice all these first three subnets are all going to be the same because we're using a class C address. And we're not doing something crazy, so it'll be that. All right. So .192. All right. Notice here, I put this IP address that's on the network, but remember 192.168.72. Remember, go by the very first network address. Don't get those mixed up. They're easy. It's easy to mix that up. Okay. So and we can tell, okay, 256 minus 192. If we didn't know this, equals. Let's get our this is where I'll use a calculator. I can do it in my head, but I just want to show you guys how it's going to work out. 256 minus 192 equals 64. Okay. So equals 64. I'm just going to put this in here for reference. All right, so I'm going to add, for my broadcast, is going to be 64, the 64th address starting here. All right, and remember, 0 is our first address in that network. So we're going to go 63. 63 plus 1 for 0, 64. All right, all these will be the same. 68, 72. All right, now it doesn't really ask this, but we're going to need this eventually for addressing, right? 192.168.72.1. Notice that was my first address that I came up with. That'll normally be your default gateway. All right, last host address is going to be one less than the broadcast, so 62. Notice here, network is an even number, broadcast is an odd number. That tells me I'm probably correct. Of course, I did calculate it out right there. All right, and I'm going to pause this video, but I'm going to make 4 more of these little calculating spreadsheets so you guys can see it. All right, so what I did, I went through here and just copied and pasted this. I don't know why that pops up. Some kind of YouTube stuff going on here. Come on, go away. All right, anyways. All right, so we've done switch 4. All right, now we're going to move down to switch 3, switch 2, switch 1, and then the router-to-router connection. So all I did was copy this, and then I just named it, or labeled it, switch 3. So the first one I needed 58, second one I need 29, third one I need 15, fourth one I need 7, and the fifth one I need 2. And that's usable host addresses, not total addresses. All right. Now if I notice here, that's my broadcast for my first one. All right. And if I look at it just quickly, okay, I want to verify. All right. 0 plus 0 as my first address plus 63 is 64. That's right. All right. I need 58. All right. Next address in our next network. And what I'm going to do is I'm going to leave off the IP address. I'll make a valid IP address in there, but for now it doesn't really matter. All right. So my next network is going to be 192.168.72. All right. 64. Notice the very next address in line. All right, first host address I know is going to be 72.65. All right, I'm going to need, well, I shouldn't say I'm going to need, I'm going to be a 255.255.255 dot, how many am I going to need for a 29 host address IPs? So I need like right there. So 30 usable host addresses would be fine. All right. So that's a .224. All right. Don't worry about this being different. Don't worry about that. We're just telling our computer and the other networking members that, okay, if I put the subnet in, I'm going to have a certain number of IP addresses, so I can tell who's a valid IP address on my network. Not really anything more than that. All right. So my last host address is going to be 192.168.72. All right. So right here it shows me I had 32 possible addresses total. All right, for a .224 address. All right. I'm talking about the 4th octet. Okay. So 30 possible addresses. So if I take the network address, all right, Let's get our calculator out. And you can do this a number of different ways, but if you always subtract, they would call the magic number 256 minus 224. What does that give you? That gives you 32. All right, 32 possible addresses. All right. So if you add not 32, but your very first address is 64. And I know they do this a little different sometimes, but 64 is my very first address, all right? And I'm going to have 32 addresses total, all right, for my broadcast, or 30 addresses for my my usable host addresses. So it's probably easier just to use my broadcast address. So if, let me get back, 224, 30, let's see, 64 is my network address. All right, so I'm going to add 30, I'm going to have 32 possible addresses. So if I add 31, and I wish it wouldn't do that, 64 plus, come on buddy, all right, there we go, 64 plus, there we go, plus 31 more equals 95. All right, so I go 95. All right, one less than that's 94. This is still going to be 192, 168, 72. And if I want to verify that, all right, I can do 256 minus 224 equals, all right, 32. Just by looking at it, I can say 32. Okay, 32 possible addresses. So if I have 60, I'm starting with 64. I add 30. If I have 32 possible addresses, that would be 64 plus 31, which would be 95. All right. Sometimes it tells you to add all of them together in -1. That's hard to. Sometimes that you can mess that up. So just think about that. Very first address is 64. You're gonna have a total of 32 addresses. So add 31, gives you 95. All right. My network address is an even. My broadcast is an odd. First host address is one more than network. Last host address is one less than the broadcast. That should be right. All right. Now what I'm going to do is I'm going to bring down, and what I can do, look in there. More than likely, this will be my subnet. And I'm not going to say it for sure, but if I copy that, my first host address will probably be my subnet address, or my default gateway address. All right, broadcast. I can take this, copy, bring it down to my next network. All right, make that one more. It's an even number, so probably that's got a 50-50 shot, hopefully. All right, the next one I'm going to need is 15, at least 15 usable host addresses. All right, so it just turns out that I'm going to have to still use the \27, which that's going to be a 254. So it's going to be 255.255.255.224. Notice we're using a class C, but so the first 3 octets we're not going to change at all. All right. So looking here, I can tell that my first host address will be 192.168.72.97. All right. Remember, if I do 256, and this might be repetitive, but it's good to repetition is good. So just get used to it. All right. So that's 32. So 32 total addresses. All right. So if I took this network address and I added 32 to it, or it's 32 including that 96. So let's see if I can do this. 96 plus 31 more for a total of 32 gives me 127. All right, 127. Oh, sorry. 127. So that's the very last address in that range. 192, 168, 72. All right. We can verify. Well, we don't really have to verify yet. We can go back and look at it, but I'll make this video 5 hours long. All right. So looking at that. All right. 224, 256 minus 224 is 32 possible addresses total. All right. Network's my first address, so minus 1 out of that is 31. What's 31 plus 20? 31 plus 96, 127. It's not even. Sorry, that's an odd number. The network is an even number. More than likely, that's right. All right. First usable host address is that, so I'm going to put that there. And coming back, that's probably going to be our default gateway. All right, now we're down to, before you start looking at anything on the left side of this, just make sure you go through and say, okay, broadcast, one more than the broadcast of the previous subnet is going to be the network address for the following subnet. All right, so add one more, 128. All right, so we need 7. So look up here. 7 host addresses. So this one, that might stick out like it might be right, but notice usable addresses, because right here require 7 host addresses. All right. Let me just verify that. Okay. So we use a /28, which is a 240 subnet. All right, 255.255.255.248. Now it's getting a little easier to calculate how many possible addresses you have when you get smaller down in there to a 28. All right, actually, let's see. I'm doing a /28, 240. Oh, almost made a boo-boo. 248, 240. All right, there we go. All right, so looking at that, 240, let's verify again. 240 gives me a minimum of 14 usable addresses. 6 is less than 7. I need 7, so I'm going to have to use that /28 or a .240 subnet mask. First address in this range is a 128. The last one here was a 127. That looks good to me. I'm just going to go ahead and say, okay, 192, 168, 72.129 is my first usable host address. All right, probably the easiest way to do this now, again, 256 minus 240 equals, all right, 16 addresses to work with. All right, and if you notice right there, 16, I needed 15 in the prior one, so that would be confusing. But remember, you have a network address to use up, a broadcast address to use up, so it wouldn't work there. I got to use it here. Okay, and now if I add 16 possible addresses, if I add 15 more to 128, because 128 is my first address. All right, 120, whoops, hopefully this works right. 128 plus, yeah, there we go, plus 15 for a total of 16 equals 143. That looks kind of weird, but it should be fine. All right, 72. All right, so 192.168.72.142. All right, let's verify. Broadcast up here was an odd number. This network is an even number. Next one in line. First host address is the one after the network. Last host is there. Broadcast is an even number at the end. I'm going to say that's right. All right, and we'll probably have a default gateway of that. I'm just assuming that right now. I'm not saying that for sure. Alright, so bringing this down and copy and pasting this thing is sometimes, that's why you got to look at evens and odds. Your networks are always even. If you brought that down and forgot to change it, you would know there's something amiss there. Alright, so now I need 2 IP addresses. Alright, right there. So 4 total addresses in that range for \30. 2 usable host addresses, that's fine. It's a .252. And that sticks out like a sore thumb to be a subnet mask for router to router configuration. Alright, so first usable host address 192.168.72.145. Alright, this is going to be kind of easy because 256 minus 252, and here I'll make it exactly the same. Alright, it's 4. Alright, so first address in that range is a 144. That's my first address. So if I add 3 more for a total of 4 to that, 147. Alright, I'm going to assume I don't need a calculator to calculate that, but who knows. Alright, 144, 145, 146, 192, 168, 72, 146, alright, 192.168.72.147. Alright, so that right there, that shows you why this right here, a \30 or a 255, 255, 255, 252 is perfect for router to router connections. Because all you got is a network address, you got a broadcast address, and then you got an IP address for each interface, one on either side of the network. All right, so that's perfect. All right, sorry. All right, so that shows you, okay, you got a Class C address, which is only a 255, 255, 255, 0, but we've already made 5 networks out of it, and really we've got 256 minus 147 number of addresses left, and 256 minus 147 equals 109. Alright, so 109 addresses left, if I'm calculating that correctly. Alright. Well, actually, it'd be, because it'd be it would be dot 148 through dot 255. That makes more sense to me when I look at it. So that would give me, I'm saying 109, but 255 minus 148 equals 107. So actually 108. 148, 149, 150, 250. That would be 103. Yep, that should be it. Alright, so that you had this left. I'm sorry, I didn't have my mic up. Alright, you had this left over. 256 minus 148. It'd actually be 109. Yeah, minus 147. Yeah, you've used up 248. You started with 0, so you minus 248 addresses so far. So what you have left over is 108 addresses. Alright, and notice if you kept going, you couldn't make an exact 108 address range, but you could still use like one with 62 addresses, one with that. You could still do a \26, a 27, and a 28 if you wanted to. All right, you don't need to, but yeah, those are left over. What you could do though, if you needed to, you can come back here and make one of these bigger, But don't think too much into that. I just want to show you guys how that'll work out. And I hope I'm not one off right there, but I don't think I am. All right. So I use IP calculator for switch 4, right? And so on. All right, so let's go ahead and move on. That right there is probably the most difficult thing. Once that's figured out, that it's a lot better. All right. So we've divided all these up. Use the 5th subnet to accommodate a connection between those. That's fine. Hey, notice also here, be on the lookout for that. Remember why these aren't connected. Remember, by default, you boot up a switch, all the interfaces or all the ports on a switch, you refer to them as ports, would be on by default. These, unless you have something, turned off, but by default these are turned off. The interfaces on a router. All right, these must have been turned on with prior configurations. All right, just recognize that. All right, so document the VLSM subnets. Complete the subnet table, listing the subnet descriptions, number of hosts needed, and then network address for the subnet, the first usable host address, and the broadcast address. Repeat until all addresses are listed. So they didn't put the last usable host address, but that would be super confusing if don't do it like that. I would do it like I did it. All right, so let me go ahead, get up here. I'm gonna fill this out real quick and then I'm gonna show you guys what I got. All right, so I think this is right. Let me look at it. Don't do full screen. All right, good. All right, so switch 4, 58 hosts. Let's look up here and see if this thing's right. All right, 58 hosts. Network address is that. All right, first usable host address is .1. Broadcast is 63, switch 3. All right, 29 hosts. If you do your calculations right and then make an error here, that's not going to be good. 95 is my last broadcast. All right, switch 2, 15, 96, 97, 127. All right, switch 1, 7 needed, 128, 129, 143. That looks good. And finally, all right, 72.144. 145 is the first usable address. 147 is the broadcast. Now, one thing, if you guys don't understand why I didn't put a address here and said, okay, that's probably the subnet, or that's probably the default gateway. Reason being, we're doing router to router here, and this is going to be the default gateway, and this is going to be the default gateway. All right. And just think about it. On a router, you have 2 or more interfaces. Each interface is going to be on a separate network, more than likely. All right. You're going to have different IP addresses sitting out there, but it doesn't really matter. Whatever is on between that interface going out, like say to another router, each of those are kind of like their own default gateways on a router to router connection. All right. That's like the next hop from you going from one LAN internal network to the outside. That remote IP address on that router on the other side of the network is going to be your next hop. All right, so I wouldn't even put that in there because that might be confusing. All right, but if I put that up there, either one of these would be valid IP addresses. Because I know in the certification exam they'll give you an IP address and a subnet mask, and they'll say, okay, is this or one of these IP addresses, are they on the same subnet? Well, when you look at it, you're like, oh yeah, that looks easy, but actually you have to do this specific calculation to find out. Because what it might be okay, here's the IP address, subnet mask is this, and is this IP address, which looks very close to this IP address, Are they on the same network? No, they're on a completely separate subnet. So, but anyways, that's how that works. That's why, yep, calculators are good to use, but you won't learn how to do it. Now I'm still crossing my fingers that I'm going to have this correct. Alright, so let's see. And be very specific for grading in here, how they tell you to document. Well, it says document the addressing scheme. You're going to have to actually configure it too. Assign the first usable IP address to remote site 1. Alright, so let me do this real quick. Well, should I do that? First usable IP address on remote site 2 for the usable IP address is remote 2 for the 2 LAN links. Assign the last usable IP address for the WAN link. Alright, so hopefully that makes sense. That's right, so let's start with this. Most of the IP addressing is already configured on the network, obviously because those 2 interfaces are already up. Implement the following steps to complete the addressing configuration. Configure IP addressing on remote site 1 router LAN interfaces. Alright, so let's do this first. Now before I do anything, I'm going to go in here and I'm going to look and see what kind of messages I have. Interface is already up for the serial connection. I'm running EIGRP. Yeah, that's it. So let's do a show run just to see what's going on here. Alright, so before I even do this stuff, I'm going to key in on what the serial interface is configured to, because I'm just curious. Alright, so 192.168.72.145. Alright, so that's as we've shown right here. Remote site 1, it's serial 000, which is right here, that little green triangle. That one's configured to 192.168.72.145, first usable host address. Now does that add up to what they're saying up here? Assign the first usable IP addresses to remote site 1 for the 2 LAN links and the WAN link. So the WAN link's already configured, so that should be good. Now what we got to do is put the 2 LAN links, which notice this actually has another serial connection. We're not going to do anything with that. The 2 gigabit interfaces, those are going to be our LAN links. So if I mouse over this, that's gigabit 01 is going to go to switch 1. So let's do that first. Alright, Control C, configure terminal. Alright, interface gigabit 01. Alright, IP address. Alright, so that's switch 1's. That's right there. Alright. That's going to get this IP address and that subnet mask. Alright. 192.168.72.129. Subnet mask is a 28. So if I memorized my borrowed bits for Class C address, 25 is 128, 26, 128, 192, 224, 240, right? So 240 should be the correct thing. Let's look up here. 240 is a \28. Did we get it right? Yes. All right. So 235.235.240. All right. Let's do a no shut. All right. I'm going to move the rest of this off the screen and just configure it. Alright, so I got that interface. Okay. So you know what I did? Did I do that wrong? Switch, did I do switch 2? Alright, so this is one of these packet tracer issues. Alright, notice that's actually gigabit 01. I configured it on the wrong one. So I can fix that pretty easy. Let's do, alright, up arrow twice. I'm going to do a alright, I'm going to do an IP address. That's gigabit 00 right there. Gigabit 00 switch 1. It's going to be, let's see, 129. Alright, so I'm going to do an exit. I'm going to do a do show run just to see what I did. Whoops. Alright, so I turned it off again, or I didn't shut it down, but I deleted the IP address out. What I need to do first is do the gigabit 00 to switch 1. Alright, Control C, interface, gigabit 00, IP address is 192.168.72.129, 255.255.255./28 is a 240. Alright, it really like that. Alright, so let's do a no shut. Alright, so we're good there. Now let's go back and reconfigure our little mess up. Alright, interface gigabit 01, which is going out to switch 2. So switch 2 is right there. First IP address. IP address is 192.168.72.97. And a subnet mask of 255.255.255.27 would give me a 224. Right. See how this thing's so squished together? It actually, it looks like it's overlapping the two. It won't let me move it either, but the two little triangles are overlapping. It looks like. It's already turned on, so we don't need to turn it on again. But we can, I mean, if we do a shutdown. Alright, notice there. And do a no shut to restart it if we needed to do that. Fast forward time. Alright, now we're good. Alright, so assign that. Assign the last usable. See, this is kind of confusing. Let's see. Alright, so that's already done. Assign the first usable IP address to remote 2 for the 2 WAN links. Alright. And then assign the last usable IP address for the WAN links. Alright. This is remote site 2. Assign the first usable to okay. Alright, notice I can't click, it won't let me click on the remote site 2. I don't have a console cable into it. And the PCs are not configured yet, I don't believe. So let's see. Let's skip down to C. All right. So assign the second usable IP addresses to the switches. So let's go up here. Switch 3. Huh. Switch 3. That's weird. Okay, so I guess what we need to do is go on switch 3. Some of the stuff is not letting us connect to it, so whatever. T. Alright. Interface VLAN 1. IP address. IP address is alright, second usable host address. 92.168.72.97 is the first one, 98 is the second one, 255.255.255. It's a \27, which is a 224. All right. Turn it on. All right. I want to look at my grading. All right. So, I gotta find the. Oh, the IP address is wrong. Okay. So default gateway, I need to configure that. All right. Assign the second usable IP addresses to the switches. All right, switch 3. Oh, duh, I gave you the wrong IP address. Let me fix that. Yep, I got a mess up here. All right, I'm going to do a no IP address. All right, and then I'm going to go. This is why you got to do it, check it, and maybe fix it. All right. So it's 72.6566. 66. It's a \27. That's correct. All right. Okay. It's already turned on, but we can do a no shut if we want to. We got to do a default gateway. Let's see. Where is the default gateway? I'm doing this a little out of order, but I'm trying to do it the way it kind of makes sense. Let's see. So define default gateway for switch 3. All right, so switch 3. All right, let's back out of that. Default gateway. I always forget that. Exit. Oh, config T. Yeah, IP default gateway. Man, it's been a long day so far. All right. So default gateway is 192.168.72.65. Notice that's our default gateway for S3's interface network. All right. So we're going to do user 4. Now, usually I don't keep looking at the assessment items, but for this, it's kind of like a little crazy. All right, because I'm looking at this. This doesn't show me anything. I filled that in. This is a little different. Alright, so let's do user 4. Alright, so let's see what it said. Assign the last usable IP addresses to the hosts. And in this case, user 4 is the only one we need to do. But we need to do, he's connected to switch 4, which makes sense. Alright. From looking at this, it doesn't show me my last usable host address. But I know 192.168.72. List within the broadcast is going to be the last usable host address, 62. If I tab down, it automatically fills in, thinking it's a Class C class full address, but our subnet mask is a 26. All right, so that's a 192, and it went away because I clicked out of it. 192.168.72.62. It is a 26, which is a 192. Alright. Default gateway 192.168. Remember, default gateway might be different. In this case, it's the very first subnet, but it could be different. 72.1. Alright. DNS server, we don't know that. Alright. So that is it. And you know what? It's almost been an hour doing this lab, so I'm not going to even do anything else. But I would obviously, when you get down here, you can only verify connectivity. What does it say? You want to verify connectivity once you do this. You can only verify connectivity from remote site 1, switch 3, and user 4. However, you should be able to ping every IP address listed in the addressing table. Alright, so for this, definitely what you need to submit in your .pka file, your completion rate right here, showing that, hey, congratulations, whatever your name was, you completed the activity, and then show me your completed addressing tables. And that's it. All right, thanks for watching.